Let's say we have two vectors, one pointing up and a little to the right, and the other one pointing right and down a bit. To add these two vectors, move the second one so that its tail sits at the tip of the first one. Then, if you draw a new vector from the tail of the first one to where the tip of the second one now sits, that new vector is their sum. Now, why is this a reasonable thing to do? Why this definition of addition and not some other one? Well, the way I like to think about it is that each vector represents a certain movement, a step with a certain distance and direction in space. If you take a step along the first vector, then take a step in the direction and distance described by the second vector, the overall effect is just the same as if you moved along the sum of those two vectors to start with. Let's see how vector addition looks numerically. The first vector here has coordinates 1, 2, and the second one has coordinates 3, -1. When you take the vector sum using this tip-to-tail method, you can think of a 4-step path from the origin to the tip of the second vector. Walk 1 to the right, then 2 up, then 3 to the right, then 1 down. Reorganizing these steps so that you first do all of the rightward motion, then do all the vertical motion, you can read it as saying, first move 1 plus 3 to the right, then move 2 minus 1 up. So the new vector has coordinates 1 plus 3 and 2 plus -1. In general, vector addition in this list of numbers conception looks like matching up their terms and adding each one together.